Let's run through what we've done in week 4 of this course. We've talked about a whole lot of different ways that you can represent compound data in Haskell. We talked about tuple types, we talked about lists, we talked about data types. So tuples are a good way of forming what you might think of as records of data. So you have in a tuple type, you have all the values in that type have the same shape, but the contents of the different fields or slots in that in those tuples might be different. So you might have a pair which has a boolean and a character in it, for example. On the other hand, lists are collections of values, but the stipulation is in order to work with the Haskell type system, each list has to contain members of only one type. So you might have a list of booleans, but that's a different type from a list of integers. We just began to scratch the surface of lists, and the next block will really spend the whole of its time talking about lists. So I won't say much more about that. But what we looked at in depth here were algebraic data types. So we saw there that types were built up by applying constructors. They might just be constructors that take no arguments, as you get in an enumerated type like the type of the seasons. But typically you get constructors which get applied to data that's part of those data values. And we saw the example of shapes where a circle takes a float as its radius and a rectangle takes 2 floats as its height and width. And we saw how to define functions over that type using pattern matching that allowed us to distinguish between the various kinds of data in the type, circles, rectangles, and maybe other things like triangles, and with a particular kind of data to extract the components so we can use them. We saw that in defining functions like the area, and you yourselves defined a perimeter function, and so on. In looking at lists, we stressed the fact that these are ordered collections of values. They're not sets or bags. And we looked at different ways that you can use generate, test, and transform to build lists from other lists. This is what's called a list comprehension notation. And one thing I conclude with is saying that originated in functional languages, but that's something else that has percolated out, and you see that in many other languages now, because it's such a nice way of defining collections in a compact and very readable way. So another place that functional languages have entered the mainstream, or constructs have entered the mainstream, is via list comprehensions. What we'll do in the next block is look at lists, look at the lists API, and get to work using the very powerful functions that sit in that API.